Okay, day 3, congruent triangles. Congruent triangles are triangles with 3 congruent sides and 3 congruent angles. So meaning the triangles are the exact same, they may just be tilted. Okay. So congruency statements state that one triangle is congruent to another and identify the corresponding parts. So if I said that triangle ABC is congruent to triangle DEF, well then I can say that AB here has one mark is congruent to DE. So AB and DE. They're also the first two and the first two. So I'm going to say DE is congruent. Now could I have said ED? Absolutely. I can switch the order. BC is congruent to FE. They both have 2 marks. AC has 3 marks. FD has 3 marks. I can also say their angles are congruent. So angle A is congruent to angle, find the one with 1 mark, D. Angle B and E are congruent. And angle C and F. Now, CPCTC, we will use that when we get to our proofs. It says corresponding parts of corresponding triangles are congruent. Corresponding parts of corresponding triangles are congruent. So if I said that these triangles are congruent, then we can automatically basically say what we have here above. We can say that AB, so we just look at the first 2, that's congruent to the first 2, DE. BC, the second 2, and the second 2, EF. We don't even need to write out the picture for this. AC, the first and last, is congruent to the first and last, DF, as segments. Then we can talk about angles. Angle A, this first one, is congruent to angle D, the first one. B and E are congruent. C and F. Float to the next page when you're ready. So congruent triangle parts can be proven from the following 3 things. The first thing is parallel lines. If I have this parallel line JD and ME as parallel, creating these triangles here, then in the image, angle D here is congruent to angle E. Now, why is that? Well, let's see here. If I were to extend this line, maybe I'll use pencil. Extend these lines, and then I have this transversal cutting through these parallel lines. Well, what do we have here? We have alternate interior. So we'd be ignoring this line. Alternate interior angles. We can say this is truth or alternate I circled alternate exterior. Alternate interior, alternate exterior, or corresponding angles. And we'll see that a little bit later. If you're having a hard time seeing that, I really encourage you to extend the lines. If you need to completely draw it outside and say, okay, this is angle D here, and this is angle E. Those were alternate interior. The next one, vertical angles, are created by 2 intersecting lines and are congruent. So if I have 2 intersecting lines here, then I can say that these angles here are congruent. I can't really just call them both angle C because they're both angle C. But I can say that angle ACB is congruent to angle, I started at A and I went down the line that had 2 marks, so ECD. Order does matter here. I can also find a triangle part that's congruent because of a common side. So I have these 2 triangles here. If 2 figures share a side, those 2 sides are congruent. So this side here for my first triangle is congruent to this same side of my bottom triangle. This is the reflexive property, if I want to say that DB is congruent to DB or BD, that is reflexive. Both triangles share the same side. That side does not change. So let's look at this next part here. It says, mark the congruent sides and angles on the figures. Use symbols and explain your reasoning. So here, if I was to extend this parallel line and extend this parallel line, it shares one transversal right here. Right? I am able to say this angle here and this angle here are congruent. Let's actually start with this transversal here. I'm able to say that this angle and this angle are congruent because those are corresponding. So I'm ignoring this transversal. This angle and this angle are congruent through corresponding angles. So I'll maybe include that, corresponding angles. So I'm going to say angle Q is congruent to angle TSU. Let's see what else we got here. I'm going to erase my transversals so I'm not looking at too much. Let's see here. If I have these parallel lines and this transversal, I can say that this angle here and this angle here, let's give them 2 marks each, are congruent. So angle RSQ is congruent to angle TUS. Again, corresponding angles. Let's think here. Can I use any alternate interior or anything like that? Well, if I'm looking at these 2 parallel lines, and I look at this as my transversal, so I'm ignoring this line here. Looking at this angle in my triangle, that'd be alternate interior to this angle here, which is outside my triangle. So that doesn't really help me much. So I think that's as much as I can get. Now, if we have that these 2 angles are congruent and these 2 angles are congruent, then automatically the third angle here and here would be congruent because they both must add up to 180. Let's do the next one. We have parallel lines running here and here, and we have a transversal running through here. I can say that this angle and this angle are congruent through alternate interior. Similarly, we can say that if we ignored this transversal and we used AD as our transversal, we can say this angle and this angle are congruent, alternate interior. I can also say that this angle and this angle are congruent because of vertical angles. So what was I able to say? We just had to mark them on there. I was able to use alternate interior angles and vertical angles. Okay, lastly, on part 3, we have this triangle here. We're able to say that XY is equal to itself because of common sides. Really, that is called reflexive. Let's add one more in. If I gave you this triangle here, and all I told you was that these 2 things are congruent, what can you add to this picture? You can add that these angles are congruent because it is isosceles. So base angles are congruent.